Hello, everyone. My name is Joey Hall, and I am a staff cloud engineer on the Oracle Cloud Customer Enablement team. Today, we are going to walk through an example of a container-based architecture using several of OCI's cloud native services. So we will start with a quick introduction to cloud native, and then dive into the use case and walk through each of the components and considerations step by step. All right, so first, the introduction to cloud native. So when we talk about cloud native deployments on OCI, what do we mean? Well, cloud native services are services that are optimized for cloud deployments. They are quote unquote native to the cloud. This means that they are designed to take advantage of the key cloud benefits such as scale, elasticity, resiliency, and flexibility because of the distributed computing model. And here on this slide, there are several areas where these services come into play. You have your developer tools, programming languages, containers and serverless platforms, which we'll touch on a bit today, data management tools, security, and the core cloud infrastructure services there at the bottom. So using all of these tools, you can create highly resilient and performant architectures, such as in the following example that we will be covering today. And we will talk through each of the relevant services individually as we go along and build out the use case. So this is the architecture that we will be building out today. The use case is an intellectual property management and distribution platform using a private blockchain. You will see the highlighted services here are some of the cloud native services from the previous slide related to the containers and serverless section. Containers are standalone units of software that are used to perform a particular task, and they can be copied, moved, replaced, scaled, and edited in an isolated fashion without impacting other containers or unrelated areas of your application. So containers are really a key component that make microservices possible, and microservices arrange an application into multiple independent services, each of which serves a specific function. So it really breaks apart your classic monolithic architecture. So utilizing these tools in our architecture, we can make sure that our application is scalable, flexible, and resilient. And when I say scalable, that means your environment has the ability to increase or decrease resources based off demand. Flexible, meaning each component has the freedom to use a wide range of technologies that is most optimal for each of their use cases. And then resilient, meaning your resources are able to be swapped out easily when a failure occurs. And because your containers break apart your architecture into isolated pieces, a failure in one container is less likely to affect another part of your application.
So now we will go into the use case and build out the architecture. These are the components that we will be using to create our architecture today, and we will cover what each of these are as we add them in throughout the presentation. And if you visit the Architecture Center or download this presentation, you can utilize these icons to help you visualize your future architectures as well.
So we will be separating the design into three layers. We have the networking layer, the application layer and data flow, and the security layer. First, we will begin with the networking layer, as this is going to be the foundation of your deployment and will structure how the services will communicate with each other.
So first here, we have our external customers and our third-party applications that will need access to our environment. And your environment will reside in what we call an Oracle Cloud region. So a region is a localized geographic area comprised of one or more availability domains. So that's going to be a collection of Oracle data centers within a particular area. And this could be Ashburn, US East, or Phoenix, US West, for example. And when you are going to provision resources in Oracle Cloud, you're going to specify which region it will be deployed in. So next we have the VCN, which stands for Virtual Cloud Network. This is a private network that you set up in Oracle data centers. The resources you provision in OCI will be associated with the VCN, and will utilize that VCN's CIDR IP range. And when you create a VCN, you're going to want to determine the number of CIDR blocks required and the size of each block based on the number of resources that you plan to attach to subnets within your VCN, which we'll talk about in a second. And you will want to use CIDR blocks that are within the standard private IP address space, and you have to make sure that the CIDR blocks don't overlap with any others in the network. So either an OCI or your on-premise data center or maybe another cloud provider that you're using. So for now, we're going to use a single network to establish network access, and we're going to call it VCN-A. So now that we have a network in OCI and users and services that need access, we now need a way for them to access our environment via the internet. So there are several types of gateways that you can use in OCI depending on the access needed. But for this situation, we will provision an internet gateway to allow access to and from our VCN via the internet. You can only have one internet gateway per VCN, and it's going to be used by all public resources within that given VCN for bidirectional internet access. And as mentioned, you can divide your VCN into smaller networks called subnets, and the subnets can either be private or public depending on the level of security needed, and the resources will receive a VNIC, which is a virtual network interface card that's going to be associated with that subnet, which is going to assign the resource a private and or public IP address. And so using subnets is a good way to segment out your environments based off of your different traffic flow and security needs. And you're going to want to use regional subnets and attach all the resources within a specific tier or role to the same subnet, so that can serve as a security boundary for that environment. So now we'll create a single public subnet to hold our load balancer. So here is our load balancer, and load balancers are used to distribute traffic to servers within your environment. Here we'll use a load balancer to take traffic from our single internet entry point, and we will route it to the appropriate resources within our environment. And there are several different routing methods that can be used to automate the traffic distribution, and you can view those different methods within documentation and pick which one is going to be best for your use case. So now we will provision 3 additional subnets to segment our network into our associated groupings. In this example, we will create a subnet for our front-end services, our back-end services, and our database services. And we are going to give them separate subnets now because each environment will have different security needs and traffic routing. So next we will add an additional VCN. We'll call it VCN-B, and this is going to be split into 2 private subnets for our Oracle Kubernetes Engine environment. And since this VCN does not need direct access to the internet and will contain private subnets, we will not be using an internet gateway. Instead, we'll be utilizing a local peering gateway, and that's going to allow traffic to flow between VCN-A and VCN-B when needed. So local peering gateways are used to route traffic to and from another locally peered VCN, and you can have more than one local peering gateway attached to a VCN, but each one can only connect to one additional VCN. So now we will do the same for our blockchain environment by adding a third VCN, VCN-C, with a subnet and a local peering gateway as well. And now the last networking component we'll look at here is the route table. So route tables allow you to add rules to route traffic from your subnets to destinations outside of your VCN. So in this case, we're going to be using our route tables to route traffic between our VCNs with either the local peering gateways or an internet gateway. And the rules within a route table will have you specify a source and a destination CIDR range, so that will determine how you would like to move or route the network traffic. So here is the networking layer at the service level, and this is again going to set the foundation for us to then deploy our other services. So the next layer we're going to walk through is the application layer and corresponding data flow. Here we're going to talk about the instances placed within our network and how they will communicate with each other for the specific use case. So once again, we have our customers and third-party application users looking to connect to services within our OCI region. And we are going to add in a third component, the OCI Marketplace. And this is what you can use to obtain many different services and applications that you can use to complement any of your OCI implementations. And for now, we're going to omit the networking layer, but we will keep a similar structure and matching groupings to go along with it. The main components you will use in OCI to group your resources will be compartments. And what compartments are, they are logical collections of resources within your tenancy, and you can use them to organize and structure your environment in different ways. So you can use them to group resources in whichever manner benefits your use case, but here we are going to keep things simple and have the compartments match what we had with our networks. But you could, again, use them to group by team, department, project, cost center, etc. All right, and we are going to add the load balancer back in because it is a major component for traffic flow within our environment, and it will reside in compartment A. Now these dotted lines here that I'm using are for the purpose of noting the separate environment subnets, and as of now these are not their own compartments, but they could be if you would like, and we'll touch on this in the security section as well, just talking about compartment structure. So now we will provision our first virtual machine within compartment A, noting that this is the front-end environment. And virtual machines are compute resources that are used to run your software. So they are built upon bare metal hardware that's within an Oracle data center, and they are virtualized into multiple VMs. So this virtual machine instance will be for our front-end software. And along with the front-end software, we will have an API gateway. And the API gateway service enables you to publish APIs with private endpoints that are accessible from within your network and which you can expose to the public internet if required. The endpoints support API validation, request and response, transformations, CORS, authentication and authorization, and request limiting. For this use case, the third-party application users and the marketplace will be directed to the API gateway via the load balancer. We will also add in a front-end portal. This will be added for customers to access the application front-end from the internet. So these customers will be directed to the front-end portal by our load balancer. And then elastic performance will be added to the environment so that we can automatically scale its performance based on demand, and you'll only need to provision the initial amount needed at the start. So if you start to get more users or more traffic from other applications, then you will not need to worry about the decreased application performance because of the elastic performance we have here.
Next, we will take advantage of Oracle Functions for two other components, the Service Bureau and the production site. Oracle Functions is a serverless platform that lets you create, run, and scale applications without managing any infrastructure. And Functions can integrate with OCI, platform services, and SaaS applications. In this particular use case, the backend software contains application logic to launch the microservice and trigger smart contracts for the Service Bureau and the production site to perform that desired task. These serverless functions allow for those tasks to now be carried out without having to deal with the underlying infrastructure. So in terms of adding scalability, flexibility, and resilience, functions do play a big role.
We are also going to utilize object storage buckets here. A bucket is a container for storing objects in a compartment within a specific object storage namespace. And these buckets can store an unlimited amount of unstructured data of any content type. So that could be analytics data and also rich content like images and videos. So we mentioned backends briefly, but there are going to be two backends for this architecture, one for accessing the APIs and the other for more traditional backend services. In our first backend environment, we will have a VM for our backend software, similar to what we have set up for the front end, and we will also add the API service to help create, manage, secure, and advertise APIs to connect to our new and existing services that we have. And elastic performance will be added here as well for scale. Now we will need a way to store information within our environment. For this, we will use a database system, and this could either be a bare metal or virtual machine database system that's provisioned and managed in OCI. So here, once a smart contract is triggered, the information will be saved into the database cluster. And we will add elastic performance here as well for scale.
In our next compartment, we will provision our Oracle Kubernetes environment. We will have VMs deployed for the Kubernetes cluster and Jenkins instances. For example, using something like a VM standard E3 Flex on Oracle Linux operating system or the compatible shape and operating system of your choosing. The Kubernetes engine will allow us to automate the deployment, scaling, and management of the containerized applications across clusters of hosts, and then the Jenkins worker nodes will be used for continuous integration in development and pre-production environments. And this is going to establish our CI/CD pipeline, so continuous integrations and continuous delivery, so that our front-end and back-end environments can communicate with our OKE environment for testing, development, and deployment of new jobs and services. And some of the major benefits you have here are decomposition, independence, and again, flexibility at scale. So containers, again, they allow you to break apart your classic monolithic architecture into smaller services that can be deployed and edited quickly. And since they are connected in a loosely coupled fashion, there are less dependencies on other systems, and they can be edited, updated, and switched out without taking down your entire application. So when you're looking to scale your application out to larger environments, this will allow for scaling of these independent systems in a more flexible manner, so you can test and iterate more effectively.
And in our final compartment will be our blockchain cluster. So since this architecture is for the use case of an intellectual property management and distribution platform using a private blockchain, the backend will run and launch microservices to trigger the smart contract, and the information from this will be registered on the private blockchain. So the private blockchain cluster runs the blockchain software, such as Ethereum, and then the backend contains the application logic to launch that microservice and trigger those smart contracts. And in our cluster, we will have a primary node and 3 secondary nodes. So these are all the primary components for data flow within our system. And now there are several services you can use from an operational perspective. The first of which is the Oracle Monitoring service. Oracle Monitoring will allow you to gain visibility into your environment so that you can have a better understanding of how your system is performing. And it can be used in conjunction with other services like health checks, events, and alarms to help you perform actions on these different insights. So the first one we have here is health checks. And health checks provide users with high-frequency external monitoring to determine the availability and performance of any of your public-facing services. So this includes hosted websites, API endpoints, or externally facing load balancers, for example. And by using health checks, we can ensure that we are immediately aware of any availability issue that's affecting your customers. We also have events. And events enable you to create automation based on the state changes of resources throughout your tenancy. We can use events to allow development teams to automatically respond when a resource changes its state. So for example, you could send a notification to a DevOps team when a database backup completes, or you could convert files of one format to another when files are uploaded to an object storage bucket, for example. And in our use case, this is particularly useful to notify users within our CI/CD pipeline. And lastly, we have alarms. And these are a part of the monitoring service. The alarms feature works with the notification service to notify you when your different metrics meet the alarm triggers. So they're going to specify specific triggers to meet these alarms. And here, you're going to want to create alarms for each desired metric emitted by your resources. So it'd be best practice to have your alarms define behaviors that are at risk or non-optimal, or if a resource is up or down. And then these alarms will notify us of these critical status metrics that, and then users can take actions on them. So this completes the second layer of our architecture, and we will now look into how to secure your environment with several of the different Oracle Cloud Security services. So for this layer, you're going to add back some of the components from previous layers to keep the architecture structure and show where these different security services can be applied. The first component that we are going to talk about, which you can see in the top right here, is the security list. And a security list it acts as a virtual firewall for an instance. So you'll have ingress and egress rules that specify the types of traffic that is allowed in and out. And each security list is going to be enforced at the VNIC level that we talked about. However, you're going to configure the security lists at the subnet level, which means that all the VNICs within that subnet, so each of your resources within the subnet, are subject to the same set of security lists. So here we will give each subnet a security list, and each subnet can have multiple security lists associated with it, and each of those lists can have multiple rules within them. So remember that when we grouped out the resources into different subnets, it was because of the different security requirements that these environments have. So here is where we can make those different distinctions. So apply those there. And the core security component that governs access to your OCI tenancy and all the resources within it is Identity and Access Management, or IAM. And IAM is based on the concept of least privilege in OCI, which means that when a user is created, they have no permissions to access anything. You must allow users to do things within your tenancy. So here, within IAM, you will create users, you'll add those users to groups, and then you will give those groups permissions to access resources in the form of policies, which is next.
So next we have policies, and policies are the statements you use to give groups access to resources. So for example, allow admin to manage all resources within your tenancy. And these policies are going to be attached at the compartment level and will apply to all the resources within that compartment. So if you have a group that you want to access these resources, they will have to be referenced within that policy. And next we have CloudGuard, and CloudGuard will be used to assess the overall security posture of your tenancy and will let you know of the potential security risks that you have within each of your compartments. So
You pick the specific compartments that you want to monitor, and then CloudGuard will show you the actions you can take to remediate those potential issues when found. So you have your identity access management to set up all your different users and the relevant permissions for access. And then you will have CloudGuard that will let you monitor all of the activity and instance configurations within your tenancy as well. And then at the edge of your application, you can also use WAF or Web Application Firewall to protect your application from unwanted internet traffic. So here we will place it with the load balancer serving traffic from the internet gateway for that reason. And WAF provides you with the ability to create and manage rules for internet threats, such as cross-site scripting, SQL injection, or other vulnerabilities. You can also have access rules that can limit access based on the geography or the signature of the request as well. And now the final service we will take advantage of here is DataSafe. And DataSafe is going to be similar to CloudGuard in that it monitors data and user activity for you to look at and take action upon. But whereas CloudGuard is at the compartment level, DataSafe is at the database level, so it's a little more granular. We will use DataSafe here to understand the sensitivity of our data, to evaluate the risks to our data, maybe even mask some sensitive data that we have. We can also assess user security and monitor user activity to address some of the different data security compliance requirements that we may have.
All right, now putting it all together, we have our container-based architecture using several key cloud-native services, all running on Oracle Cloud. We separated this diagram out into 3 major layers throughout the presentation, but they all came together into a cohesive system that is performant and secure. Now, I hope this video helps you understand the different components that you can now utilize to create your own environments, and will provide some guidance for your designs in the future. So thank you all for watching, and I hope you have a great rest of your day.